Now, this procedure will be applied to slightly more complicated functions. So 3.3, you can say these are complicated enough. I agree. So we're talking about rational functions. Rational functions, they're not more complicated, but they have something called asymptotes that we haven't seen before in the other problems. Asymptotes. There are three different types of asymptotes: horizontal, vertical, and slant, also called oblique. So we've seen these before, but let me clarify them again. So here's a function with a horizontal asymptote. The horizontal asymptote deals with infinities, but I cannot graph a line without graphing the middle. But it has no meaning in the middle. It's all the way to infinity, and it's all the way to negative infinity, but I cannot graph a line just showing this line, this piece here, and this piece here. So I have to graph the entire line. And this is a horizontal asymptote. So I'm going to say y equals 2 horizontal asymptote. How will the graph look like? This is, the asymptotes are not part of the graph, but they have to be graphed. So they are graphed as dashed lines, but they're not part of the graph, but they have to be on the coordinate system. So for example, this is an example of a function with horizontal asymptote, y equals 2. As you see, the function values get closer and closer, closer and closer to y equals 2, to 2, as x approaches infinity. And the function gets closer and closer, closer and closer to 2, as x approaches negative infinity. We've seen something like this before. We haven't talked about it in terms of asymptotes. Okay. So that's how the horizontal asymptote works. How do I find it? By finding the limits to infinity. If the function approaches a number, then I know that that's a horizontal asymptote. The functions we are going to look at will have the same asymptote on both sides, but that's not always the case. A function can have this asymptote and this asymptote, and do this and do this. In other words, at positive infinity, it has y equals 2. At negative infinity, let's say it has y equals negative 3. This is possible, but not pure, simple rational functions. The simple ones, they have the same asymptote on both sides. Okay, so that's the horizontal. How does the vertical look like? Although I just showed you there, let's do another one. So here's for the vertical. Not part of the graph, but it has to be graphed. Let's say x equals 3. And let's say the function does this. As x approaches 3 from either side, the function values get closer and closer, closer and closer to infinity. This is a vertical asymptote. How do I determine it? By finding the limits as x approaches 3 from either side. Here, I have to find the limits at infinity for the horizontal, but for the vertical, I have to find the limits as x approaches 3, in this case, from either side. Okay, horizontal, vertical. What about slant? A function cannot have horizontal and slant at the same time. slant and horizontal cannot exist at the same time. In the same function. Horizontal with vertical? Yes. Slant with vertical? Yes. Horizontal with slant? No. Okay, so a function can have a slant asymptote, which means not vertical, not horizontal, but something like this. That's a slant. And let's say I'm going to put in a vertical, and I'm going to graph it now. This is the graph of a function with a vertical and a slant. Here's a piece, and here's another piece. Good. So this is an added element to everything that we need to look at. And now everything else is the same. We just need to practice. So page 305. Now let's choose anything you like. Here they're asking us just to find the vertical asymptotes and the horizontal asymptotes. Let's start with that. And then we put everything together with a graph. So let's first look at 1 through 16 to find vertical asymptotes. Let's choose any function you would like to pick to find the vertical asymptotes if they exist. If you don't pick, I will.
Can we do number 8?
Yes, number 8, perfect. So in number 8 on page 305, the function is f of x equals x plus 6 divided by x squared plus 7x plus 6. Perfect pick. You will see why. Good. So vertical asymptotes exist when the denominator is 0, in other words, the function undefined, except when a factor disappears. What does this mean? What does this mean? Okay, so let's look at this function. I'll explain. Can anyone give us the factored form of the denominator? Perfect pick, Jesse. Thank you. That was a good one.
Be
Ready?
would be x plus 6, x plus 1.
Yes. Let's state the domain of this function. What will you say first? What are the restrictions?
-6 and -1.
After I write the restrictions, I'm allowed to simplify. Is there any factor that I can simplify? Only after I write the restrictions. Is there any factor that I can simplify? Is there?
X plus 6.
Of course. A vertical asymptote exists when the denominator is 0, except when a factor disappears. So this is not a VA. It disappeared. It was simplified. I should not write disappeared, but just simplify. It disappeared. It went away. So this becomes a hole in the graph. This is a hole in the graph. This one stays. So x equals -1 is a VA. So when I'm given a rational function, and if the denominator can be 0 for certain values, those values are in question. They can be vertical asymptotes, except in the situations in which, in the simplified form, a factor disappears, was simplified, then that factor, in other words, x equals -6, is no longer a VA, not a vertical asymptote, but it's a hole in the graph. So this graph has only one vertical asymptote, x equals -1. So how will this look like? So I would like to graph this function with the whole thing. I see we have 7 minutes left. I may not have enough time, but we'll start. So I just want to show you the preliminary, and then we will do the whole thing with the table and the graph correctly. So at x equals -1, this is definitely the vertical asymptote. But what happens at -6? 1, 2, 3, 4, 5, 6. Here's -6. When I plug in -6 in the simplified form, 1 over -5. So this point is right here. It will be an open point. And the graph, you'll see, it does this. Going through the open point. Because the factor disappeared. So, because as I said, we only have 6 minutes left, we're going to do this on Tuesday. I'd like us to choose other examples, other problems to simply determine the vertical and horizontal asymptotes, and then we'll come back to and work on the entire problem next time. Do we need to illustrate vertical asymptotes again, or can we move on to horizontal?
We can move on.
Okay, so let's choose one for horizontal, from 17 to 28. 17 to 28. One example from 17 to 28. And I have to mention something before you choose. Same degree over same degree. Is one situation. Situation number 2. Degree n, degree greater than n. Greater than n. That's such situation 2. Final situation, degree n plus 1 over degree n. So what am I saying here? The first one and the second one have horizontal asymptotes. The third one has slant. So if I have a rational function with degree 2 over degree 2, degree 3 over degree 3, degree 1 over degree 1, it will have a horizontal asymptote. If I have a rational function with degree 1 over degree 2, degree 3 over degree 10, degree 7 over degree 11, more in the denominator than numerator, it will have a horizontal asymptote. This one is the only one that has slant, and it will not have horizontal. It may have vertical, but not horizontal. Degree n and degree exactly n plus 1. So degree 2, degree 3, degree 4, degree 5, degree 1, degree 2, exactly by 1 unit higher than the degree in the denominator. That will have a slant asymptote. Okay, so now let's just look at, allow me to choose this time, and then you will choose next time. Okay, so 19. The last problem for tonight. So 19 on page 305, and we have f of x equals 4x divided by x squared minus 3x. Okay, so I realize that I can also simplify factoring out an x and x minus 3. Of course, x cannot be 0, x cannot be 3, and I'll simplify and make my life easier. 4 over x minus 3. So this is a simplified form. When we talk about horizontal asymptote, we have to find limits at infinity. If it is a number, then that is the horizontal asymptote. So when we plug in infinity, the numerator is 4, and the denominator is negative infinity minus 3. What type of number will that be? Or symbol? How much is negative infinity minus 3? Negative infinity minus 3. What could that be? Please, anybody? Well, it's negative infinity. How much is 4 divided by negative infinity? 4 divided by an extremely large number. Anybody? 0. When we divide 4 by something huge, we always get 0. Because we got 0, y equals 0 is the horizontal asymptote of this function.